Hello everyone, this is Dr. Lennon. So today we're going to start off talking about linear functions and models. So linear functions are exactly what they sound like. They are the class of functions whose graph is going to be a line. So a linear function, and just for future reference, often I will abbreviate function by FCN. So a linear function is one that may be written in the form y equals mx plus b. This is known as the slope-intercept form of a line. There are other forms as well, but this is definitely the most encountered. So the parameter m represents the slope, and if you have 2 points with coordinates x1, y1, and x2, y2, then you can find the slope by doing y2 minus y1 divided by x2 minus x1. So probably pretty familiar with that. And then b, we say, is the y-intercept. So I'm writing b equals the y-intercept. Technically that's incorrect, because what we really mean is, right, 0 comma b is a point on the y-axis. So when I write b equals the y-intercept, technically it should be an ordered pair of points, but I'm just kind of abusing the notation there. And then lastly, as we mentioned, the graph of a linear function is a line. So there's a number of things we'll want to be able to do. If I can see an equation in this linear, in the slope-intercept form, can I draw its graph quickly? If I know some information about the line, can I write down the equation? So those are two of the fundamental math mechanisms you want to be able to do in terms of this style of problem. So let's first look at the problem of sketching the graph of the line given the equation. So sketch the graph of each function. So I'm going to show you a quick way to do that. Rather than plugging in a bunch of points, we'll just appeal to the y-intercept and the slope. So let's first look at, say, f of x equals 2/3 x minus 1. And we want to graph that. So to do that, what we'll first look at is the y-intercept. So if we come over here and draw a Cartesian coordinate plane, it hits the y-axis at -1. So we first locate that point. Then from that point, we can view the slope as a set of instructions that will guide us to another point on the line. So since the slope is 2/3, that means if we go up 2 units and right 3 units from that point that we've located, we will find another point on the line. So up 2 units would bring us here, and then to the right 3 units would give us this point right here with coordinates 3 comma 1. So then again, the line is just the found by going through those 2 points. 2 points are enough to uniquely determine the line. So if you notice, the another way to think about it from a solving equations perspective is that you have 2 kind of parameters you need to find to understand the equation of the line: m the slope, b the y-intercept. So if you had 2 xy points to plug in, then you would have 2 equations and 2 unknowns. And so typically you're able to solve that. So b, let's look at g of x, and this one has equation -5/2x plus 2. So our y-intercept this time is now above the x-axis, so it's on the y-axis with value 2. And then the slope this time is -5/2. So the thing about -5/2 is -5/2 can be written in 3 ways. You could think of it as -5 divided by +2, or you could think of it as 5 divided by -2. So what are the consequences of that? Well, the orientation of the Cartesian plane has two directions, right? Left and right and up and down. So to the right is the positive direction horizontally, and up is the positive direction vertically. So traveling from our point that we've located on the y-axis, there's two ways to do it. So we could either say this is going to be going, if we look at -5 divided by 2, it's change in y over change in x, so that would be down 5, right 2. Or if we think of the -2 on the bottom, that would now be saying +5 on top, which would mean up 5 and left 2. So you'll find two different points, but the graph that you get either way will represent the same line. So let's look at first down 5, right 2. So down 2 and then 3 more. And then to the right 2 will give us this point right here with coordinates 2, -3. And then if we happen to go up the other way and left, we would find another point on the line. So I'm not going to draw that one, but suffice it to say, it will yield the same picture. Okay, so graphing these is pretty easy. Let me look at one more example. Just so far, both slopes were fractions. What if it happened to be a whole number? So let's say we had, I don't know, h of x equals -3x plus 4, something like this. Well, our y-intercept is at 4, so all the way up here, and then it's -3, so -3 as a fraction we can always think of as -3 divided by 1. So this would be down 3, right 1. So down 3, right 1 would give us this picture right here. So pretty quick and easy way to find the graph of any linear function. So now let's talk about finding their equation. So there's two ways to do it. One way relies on a formula known as point-slope form, and the other relies on just plugging things into the slope-intercept form. So I'll show you both ways. Typically, I'm not going to use point-slope form. I think it used to be more common, but now it doesn't seem to be. I don't know. You know, the merits of one over the other are kind of minor. So point-slope form. So the formula looks like y minus y naught equals m times the quantity x minus x naught. So what is going on here? So where m is actually the slope and x naught, y naught is any point on the line, any known point, let's say, on the line. So those are constants in this formula. They're not varying quantities. So you've got three constant parameters here rather than the two above. But a lot of times you might know the a point and the slope. But okay, so the kind of argument in favor of not using this is, well, you're memorizing a formula and that's not really contributing to understanding. But I would push back there just in the sense that this formula is actually related to one that you have to know anyway. So let's make a little comment on that. So point-slope form is really just the slope formula in disguise. So if you have m equals y2 minus y1 over x2 minus x1, and you cross multiply, you just end up with m times x2 minus x1, which equals y2 minus y1. And then basically that's all you're doing is you're relabeling x2 and y2 as varying quantities, hence variables. And you're saying the x1, y1 that we're using here, we're just going to relabel it x0, y0. Typically that's notation for initial quantity. But you're kind of just calling one of the sets of parameters in the slope formula a varying quantity and then relabeling the other one. So if you know the slope formula, you should know the point slope formula. So that's my only comment on that. That's not really how you would use it, but it does relate to where it comes from. So let's just look at a simple example where we use both methods. So that example is, we're just going to find the equation of the line that passes through (1, 4) and 3, 1. So we'll do this both ways. Method 1, we'll use the point slope form that we just wrote down. So method 1, use point slope form. So here we have m is equal to, so I'm just going to do them in order. So I'll call 3, 1, x2, y2, and I'll call 1, 4, x1, y1. So we get 1 minus 4 divided by 3 minus 1, and that leaves us with negative 3 over 2. So then we can just plug whatever we need into the point slope formula. It's up to you whether you want to use 1, 4 or 3, 1. I'm going to use 1, 4. So we have y minus the y coordinate of 4 is equal to this negative 3 over 2 times the quantity x minus 1. And then a lot of times they will ask for the answer. They may specify your answer needs to be in slope-intercept form. So what that means is you just have to distribute the negative 3 over 2 and then add 4. So we're just solving for y. So if you do that, we have y minus 4 equals minus 3 over 2 x plus 3 over 2. And then you would add 4 to both sides. So doing that results in y equals minus 3 over 2x plus 11 over 2. Or if you want to use fractions, you could have written it as y equals minus 1 point, if you want to use decimals, you could write it as y equals minus 1.5x plus 5.5. So that's method 1. Method 2 is just going to utilize the slope-intercept form. So method 2, what are we doing? Basically, we're just solving for b and y equals mx plus b. Now let's note that we would need to find the slope just as in method 1. But I'm not going to go through that computation again. It's relatively simple. And you can just read above. So what do we have? We have y equals minus 3 over 2x plus b because we found the slope. So now what you can do is you can plug in either one of those 2 points for x and y respectively, and then just solve for b. So we could replace y by 4 and x by 1, and then solve for b by adding 3 over 2. So this is basically from plugging in (1, 4), and then we have 11 over 2 is the value of b. So again, we would want to rewrite our final answer using that slope-intercept form. So we end up with y equals minus 3 over 2x plus 11 over 2. Same answer we found above, just slightly different method. not using that point slope formula at all. So let's talk a bit about parallel and perpendicular lines. So these are some features that come up occasionally. So what is the relationship between them? So the relationship involves their slopes. So let's see. Parallel lines have exactly the same slope. Whereas perpendicular lines, so what does it mean to be a perpendicular line? It means that the lines intersect at a right angle. What is the relationship between their slopes? Well, their slopes are opposite reciprocals. So these have opposite reciprocal slopes. Erase that. So for instance, if L1 is perpendicular to L2 and L1 has slope 2/3, then what should be the slope of line 2? Then it would have to be the opposite reciprocal. So L2 has slope -3/2. So you change the sign and you flip it over. That's what it means to be an opposite reciprocal. So let's go ahead and do a couple examples. So the first, let's find the equation of the line that let's say is parallel to 5x minus 3y equals 12 and passes through let's say 1, 1. So the equation of the line that we're looking at, 5x minus 3y equals 12, that's actually known as standard form or general form, one of those two. And it's not immediately obvious what the slope is there. So first we want to figure out the slope. Once we know the slope of that line, we know that our line will have the same exact slope since it's parallel. So what we want to do is we want to take that equation, 5x minus 3y equals 12, and solve for y. So basically we want to subtract 5x, and then from there we're going to be left with -3y equals minus 5x plus 12. So divide by -3 to isolate y, and that will allow us to see the slope more clearly. So we'll have y on the left. On the right, we'll have minus 5x over minus 3 plus 12 over minus 3, using the common denominator to separate the two terms in the numerator. So that ends up as 5/3 x minus 4. We actually don't care about the minus 4. We only need to know that 5/3 is the slope. So that means our line has equation y equals 5/3 x plus some value of b. since it is parallel. Let's say since it is parallel to a line with slope 5/3. Okay, so then we use the same trick, just plug in 1, 1 and solve for b. So 1 equals 5/3 times 1 plus b, and we just subtract 5/3 from both sides. So we get b is -2/3. So the equation of the line we're looking for is y equals 5/3 x minus 2/3. And that's our answer. So let's go ahead and look at an example where we determine the same thing, but perhaps the relationship between the lines is perpendicular. So example, let's find the equation of the line that is perpendicular to y equals 5x plus 7 and passes through 2, 3. So this line has slope 5, so our line has slope minus 1/5, since it's the opposite reciprocal. Right, so just remember that. So that means our line has to look like y equals minus 1/5 x plus a y-intercept value of b, and then we want to plug in our point 2, 3. So 3 replaces y and 2 replaces x, and then we just go ahead and solve for b. So we have 15/5, getting a common denominator, equals minus 2/5 plus b. So add 2/5 to both sides, and we see that b is going to have a value of 17/5. So the equation here is y equals minus 1/5 x plus 17/5. Or if you prefer decimals, I tend to work with fractions when they're there, I just don't notice. But you could also write this as a decimal equation, y equals minus 0.2x plus 3.4. Either way, that would be your final answer. Again, when it comes to submitting it, if you have an online homework question, something like that, you may have a method that it requires to input the answer, whether it be fraction or decimal. So let's go ahead and look at an application problem here. So in application problems, often we're interested in units. So we know that x and y are going to have typically different units, some unit for an input value, some unit for an output value, but how does that relate to the units of the slope? What is the slope measuring? Well, the slope is measuring a constant rate of change. So a rate is typically going to have 2 units, right? It's going to have 1 unit per another unit. In this case, since the slope is computed using change in y over change in x, that's exactly what the slope units are going to correspond to. It's going to be the units of y over the units of x. So, for instance, if you had some function measuring displacement in miles with an input unit of time in hours, then your slope would be giving the constant rate of change, which would be miles per hour. So let's just make that comment. So note that in application problems, the slope will always be interpreted as a ratio of units. That is, units of M are exactly the units of Y over the units of X. So let's look at an example. Let's say the owner of a car wash business estimates that it costs C of X equals 4.5 X plus $340 to wash X cars in one day. So let's say A, what is the rate of change? And so let's interpret that. So the rate of change is just the slope. Clearly C of X equals 4.5X plus 340 is in slope-intercept form already. So the rate of change is 4.5. So what are the units of this quantity? The units are the units of the output, which are dollars, over the input, which are number of cars. So if you want to think about 4.5 as a fraction, it might be helpful to think of it as 4.5 divided by 1. You can always do that, and it helps write the sentence that interprets the rate of change here. So basically it's telling you that each additional car washed increases the daily cost by $4.50. So I suppose if this data is accurate, if you see a sign for a $5 car wash, that's a pretty good deal. All right. So what about the, let's call it, for lack of a better term, what is the C-intercept? Because it's C of X rather than the Y-intercept. And let's interpret that result as well. So the Y-intercept is just the value of Y, or the value of the function, at an input value of 0. So essentially the intercept here, if you go back up, again, my touchpad mouse isn't very good here, but it's 4.5x plus 340. So our y-intercept is 340. So that's the value of the intercept. Again, this is representing the ordered pair 0, 340, but let's just write down the intercept is 340. So what are the units of that? Well, the units of that are going to be dollars. And they're going to be dollars when you're washing 0 cars. So essentially that's telling us the fixed daily cost of this operation. So the fixed daily cost of the car wash are $340. All right, so that should be it in terms of linear functions, so hopefully that was a good review. If you have any questions, please let me know. Otherwise, this is Dr. Lennon signing off.